Hey everyone, in this video I'm going to cover the solution for this specific Leetcode question called word search 2. And also at the same time I'm also going to cover the general procedure, how we should behave in a real interview. So let's get started. So in the real interview, the first step is always try to fully understand the problem. If there is anything unclear, please bring up the question to the interviewer, and at the same time think about some edge cases. So let's read through this problem. So given a m by n board of characters and a list of the strings words, return all the words on the board. So each word must be constructed from letters of sequential adjacent cells. So the adjacent means horizontal or vertical neighboring. So the same letter cell may not be used more than once in the word. So example 1, so we have the board like this, and we have a set of words, and only it and the os are the two words that can be constructed from the board. So for this one, there's no, so ABCB cannot be constructed from the word. So let's see some constraints. It says that the board is never going to be empty, and also the board is lowercase English letters. And also the word length, each word is, so the words array is not going to be empty, and each word is not going to be empty either. So word I consists of lowercase English letters, and all the strings in the words are unique. So let's take a look at the solution. So the next step after you're done with the first step, which is about understanding the question, the next step is to find the solution. So you will need to discuss the idea how to solve this problem, do some necessary runtime space analysis, and after you get an agreement, then it's a step for you to start to do some coding work. So let's take a look at the solution and go through this piece of code. So the solution is, so the general idea is to do recursion plus backtracking, and at the same time we use the prefix tree or try to do branch cutting to try to limit the scope or the space we do the search. So let's see, first of all we define this tree node. So there's three things: whether the tree node is a word, and if it is a word, we are going to have the word for the tree node to be stored, and also we have the map of the children. So the map is a corresponding character, and the value is a corresponding tree node. So you can see that we have a constructor for this, and also for the try, how we define a class called try. We define the root node for the try, and the constructor is pretty much just renew a try node. And also we define a member function which is insert. So the insert is to insert a word into the try. So we start from the root, and if the corresponding character exists in the node.children, then we just go to the corresponding branch. Otherwise, we will need to create a new children node for the corresponding character and then insert it. And finally, when we arrive at the end, we need to mark the node is word as true, and then we start the words. So that's about the try. So the next part is about implementing the find words. So here we define a helper function which is generally to change the set of the words into a list of the words. So I'll just close this one. And the next, let's see the body of this function we implemented. So at the very beginning we initialize the try, and then we insert all of the words from the words array into the try, and then we have a visited hash set, which is for the purpose not to visit the same cell more than once. And the other one is the final words, which means if we can find the word within the grid, then we just add the words, add the corresponding word into the set. So you see that we go through every cell. If the character exists as the first child of the root, then we are going to call this recursive function to start from the place ij, and starting from the first node, which is root.children.get the corresponding character. And then we pass in the visited and the final words into it. And then finally we call the setToList to return a list of the string. So let's see the helper function, which is a recursive function. So we pass in the board, the corresponding row and column, and the node it is currently at, the visited set, and the word set. So if the node.word is marked as, if the corresponding node is a word, then it means that we can construct the corresponding word from the grade. So we are going to add the node.word into the word set, which is the final result set. And then we are going to have the corresponding position to construct it as a pair, which is used which is used by the visited part. Then we have the neighbor. So this is upper, this is lower, this is to the left, this is to the right. So we go through all the 4 neighbors. We add a current position into the visited, which means we have visited this position, and then the new row and column is pretty much the neighbor cell we are going to visit. So we have a new pair, which is a new position we are going to visit. Should search is a helper function to say whether the next cell is okay for us to continue the search. If it's not okay, then we are not going to call this recursive function. So this one is for the purpose to cut the branch. And then because we do backtracking, we are going to remove the position from it after this loop. So let's see, for the should search, essentially the first condition to see is if the row or the column is out of the range, then we return false. The second one is to say if we have already visited the corresponding position, we just return false. And the next one is to say if the corresponding character in the board is one of the children for the node, then we are going to return true, otherwise return false. So this is where we use the prefix tree or trie we have constructed. So if for this node it doesn't have a children, it doesn't have a child which is the character, then there's no need for us to continue to do the search from that direction. So that's essentially how we use the try to cut the branch and how we implement the recursion plus backtracking to solve this problem. So the runtime for this, overall, for the worst case, I would say it could be, let's say if we have, so it really depends. So for each position, so let's say it is m by n, so of course we are going to have m by n, and for each m by n, we will potentially we will need to search the whole tree. So essentially when I do the runtime analysis, I'm talking about this part. So you see that we go through each of the row and the column, and we call the find word. So if everything within the cell, if everything within the board, if the condition for, like, essentially I'm saying if condition is true for every of the cell, then that's the worst case, and we call the find word. So let's say the find word, the condition we are going to stop there is pretty much we search the whole tree. That's a worst case. Yeah, so if that is the case, so we go to one branch and then we go to the next. So yeah, so for this one, I would say the worst case it is still to do for all of the, like for this find word, we are trying to do the search on each of the neighbor, which is for direction. So the worst case, let's say the longest word has a length L, that is going to be m times n times 4 to the power of L. So we have this two layer of the for loop, which is m by n, and for this find word, it is, so for this find word, we are going to visit all of its 4 neighbors for the worst case, and when it comes to like the height of, when it comes to the height of the tree, which is the longest length of the length of the longest word, then that's pretty much the most time consuming part for this find word. So I would say, to suppose the longest word has a length as L, then the worst case is going to be O m times n times 4 to the power of L regarding the runtime. So that's it for this coding question. Remember, after you're done with coding, you also need to do some testing. If it's a runnable platform, feel free to run it by setting up some test cases. If not, then you need to go through the test case manually to explain how this piece of code is gonna work and do some sanity check. So that's it for this question. If you have any question about the solution or about the question itself, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.